In this video, we're going to look at everything you need to know about geometric sequences and series. What is a geometric sequence? Consecutive terms have a common ratio. And to put that another way, to move from term to term, you multiply by the same number. I'm going to put a couple of examples on the board. So you can see in this sequence, to move from one term to the next, you multiply by 3. And in my second sequence, to move from one term to the next, you times them by a half. Yeah, commonly defined as geometric sequences have a common ratio between consecutive terms. And what we mean by that is, if you take consecutive terms that are next to each other, and you divide them, you always get the same result. So if you divide these two, you get 3, these two, you also get 3, these two, you also get 3, and so on for any two consecutive terms. There is some notation you must be familiar with for geometric sequences, so we'll get that on the board now. The first term is always represented with the letter A, and then the number you multiply by is R. So my second term will be AR. Third term, times this by R, I get AR squared. Times this by R, I get AR cubed. And so on and so on. The numbers in my sequence are called the terms. And if I'm talking about a particular term in the sequence, I'm referring to its, well, if I'm talking about where it is, I'm talking about the position of the term. Oops. So we've got term 1, term 2, term 3, term 4. Okay, and that can go on forever if it's an infinite sequence, or it might be a finite sequence that will have an ending, in which case I'll say the last position is n. N generally represents the general term in the sequence. Sorry, it represents the general position. And the question is, what is the nth term? You can probably see a pattern between the positions and the terms. Nearly all of these terms are A multiplied by R to a certain power. And you can probably see the power of R is always 1 less than the position. The power of R here being 1. So position 3, power of R is 2. Position of 4, power of R is 3. Which means for our nth term, it's going to be A times R to the power n minus 1. Okay, alright, and this is called our nth term, so we can write that down like this. That's a formula that's not given in the booklet, so you have to remember it off by heart. This is a geometric sequence. A geometric series is when you add the terms together. And just like with arithmetic series, it's denoted by the symbol letter Sn, which means the sum of n terms. And all Sn is, I'd simply write my terms again, but summed. Okay. And there is a formula for Sn as well. Fortunately, let's put a box around it. Fortunately, this one is given in the formula booklet, but your teacher may want you to remember it or not, I don't know. It's probably a good idea to remember it. You should have done, by the time of the exam, you should have done enough practice that you would kind of just remember this off by heart anyway. And finally, there are 3 words you must be familiar with to describe geometric sequences and series. Firstly, when is a series alternating? That's if the terms go from positive to negative to positive to negative. And the question is, what's the condition for the terms to go from positive to positive to negative? It's if you're timesing by a negative number. So up here, instead, if we were multiplying by minus a half, it would go 80 minus 40, 20 minus 10. So that's an alternating sequence. And I'll put the condition down here and the definition. Right. If you have a common ratio that's negative, it's going to be alternating. Right. Convergent, this is referring to series, in particular infinite series. Sometimes if you just continue to add the terms of a series forever, sometimes they tend towards a limit, sometimes they don't. When they do tend towards a limit, the series is described as convergent. And the condition for a series to tend to a limit, to be convergent, is when r is between minus 1 and 1. We're going to look at this a bit more in another video, but for now we're just going to define it. If a series isn't going to tend to a limit, it will be divergent. And as you add the terms to infinity, the sum will blow up to infinity as well. So we'll define this as an unbounded series. And again, this is a way of saying, okay, the common ratio is not between minus 1 and 1. So it's either going to be bigger than 1 or less than minus 1. Just make that an equal sign there. If r is between minus 1 and 1, Sn is convergent. And that means that as you continue to add terms on, it's almost having no effect on the overall sum. And it makes sense, because if r is between minus 1 and 1, something like a half, then when you come to add on the 100th term and the 1000th term, which you work out using this formula, you're going to have a half to the power 99 or a half to the power 999, which is going to be very, very small. Consequently, it's not going to have much of an effect on the overall sum when you add these later terms. And as you continue to add terms, you can say that the sum it approaches a limit. You can see it's getting closer and closer to a number. There's a way to work out that limit. There's a formula. So Sn, as n gets very, 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 very large, the way to work out what the limit is, what that sum is approaching, is a over 1 minus r. And it only works when r is between minus 1 and 1. It's not too difficult to see where it comes from, actually. If you think about the formula for Sn, it's that there. Now, if n is getting very, very large, then this term here is going to approach 0. remember, r's between -1 and 1. So when n's really large, this is going to be a half to the power 100, a half to the power 1,000, a half to the power 1,000,000. So this here is approaching 0, and it becomes that's what it's getting closer and closer towards, but this term here is 0. And if you neaten this up, you get a over 1 minus r.